All right, we're going to take a look at section 5.2, which is titled Dividing Polynomials. So we're going to start with some ones where we don't really have to do the long division that we talked about last time, or even synthetic, but using some of the power properties from the last section. So let's start by dividing. We're going to take, so this will be number 1. We're going to take 20c to the 4th d squared f minus 16 c d f squared plus 4c df, close the parentheses, there's one polynomial, and we're going to divide that by 4 cdf. So we're going to try and do, I can write this in fraction form if you'd like. Notice this first polynomial, they are not like terms. They include the same letters, but they don't all have the same letters in exponent in combination anyway. So we can't combine them all together. Now the only way we can simplify this fraction is if I can divide out something from the denominator that can be divided out of every term in the numerator. So what I could do is I could factor the numerator first, or I can just kind of go one piece at a time. Like look at the 4 here. Can I divide every piece of it by 4? I can. So I can divide that by 4, which is of course going to become a 1. 20 is become a 5, 16 a 4, and 4 a 1. And then look at c. Does everything have a c in it? Yes, it does. So I can divide out the c. So c to the 4th, I removed a c, so that's going to leave me with c cubed. This only has a c, so the entire c is going to be gone. This one only has a c, so its entire c will be gone. Do the same thing with d. Does everything have a d? Yes, it does. So I can get rid of the d. D squared becomes just d. That entire d is gone, that entire d is gone. With f, everything has an f. So f's gone there, my entire f's gone there. F squared becomes just f. And that entire f's gone. So in total, I get 5c cubed d minus 4f plus 1. It's all over 1, so I don't need to write it as a fraction. Now I couldn't do that simplifying unless I can take it out of every single term, so make sure you're careful about that. Okay, next, let's take a look at what we call synthetic division. We won't always be able to use synthetic division. We can use it, so may use, when dividing by a linear, so not quadratic, I'm going to call it a linear binomial with lead coefficient of 1. Seems like a lot of rules. It's actually not exactly true that this is the only time we can do it. The book talks about using lead coefficients other than 1, but it's my opinion that it's easier to just do long division like we did last time instead of using synthetic division in those cases. So, so let's go ahead and take a look. This will hopefully make sense when we start seeing some of the problems. So we're going to first take x squared plus 7x minus 30. And we're going to divide it by x minus 3. So we're dividing by x minus 3. This is the part I was talking about in the parentheses up here. A linear binomial. Linear means it has an x. It's like y equals mx plus b type of thing. It has an x and maybe a constant. So this has an x, no x squared. So it's linear. It's a binomial, has 2 terms. The lead coefficient, the coefficient on the x, is just a 1. If it has something other than a 1, I'm not going to use synthetic division. So this one meets the requirements that we're going to look at in order to use synthetic division. So since it meets that, what I'm going to do is take the original the one that I'm dividing, this polynomial, look at its coefficients. Make sure the degrees are in descending order, so degree of 2. This doesn't have an exponent, so we know it's a degree of 1, and this doesn't have an x, and also it's a degree of 2, or 0. So 2, 1, 0. It descends all the way down. We don't have any missing terms. If you do, we need placeholders. I'm going to write those coefficients, not with these x's, but just the coefficients. So the first coefficient was a 1, so I'm going to write it down. I'm going to leave a little room in front. In fact, I'll put a little half box there that I'll come back to. But I got a 1. The next lead coefficient is a positive 7. And the next coefficient is negative 30. Those are all my coefficients. I just kind of list them all in order. In this half box in front, I'll take a look at what I'm dividing by, x minus 3. So if x minus 3 is the factor, we want the solution. This should ring a bell from last chapter. Like if x minus 3 is the factor, what's the solution? You would set x minus 3 equal to 0, and you would solve. You'd add the 3 over. So really, in essence, what you do is just change the sign. If you have x minus 3, we're going to put a positive 3 there. I'm going to leave a little space, like another row below it, and put a horizontal line. And below my last term, I'm going to drop a little vertical bar. We're going to be putting numbers in above this line and under the line. That's how I initially set up the problem. Now here's the process of synthetic division, and our book runs through it fairly well. I think if you get lost here, you can look back at the book. But what you always do is the very first coefficient, you're just going to drop it straight down below the line. The numbers that end up below the line are the ones I care about. Once you get a number below the line, you're going to multiply it by this number in this half box. So 1 times 3 is 3. That's what you're going to write underneath the next one. So underneath the 7, write the 3. 3 times 1 was 3. You're going to write that 3 there. And then what you're going to do is you're going to add those two numbers together, the 7 and the 3. 7 plus 3 is 10. Write that below the line. Then since we got another number below the line, you're going to multiply it by the number in the box. 10 times 3 is 30. So write 30 underneath the next coefficient. Add them together. Negative 30 plus 30 is 0. Now this last number, I'm done now. This last number, the one that's after that vertical bar, that's my remainder. So preceding it are the coefficients of my answer. Now those are the coefficients. We need to then put in the variable pieces. So how do we know what we started with? Think back to what you started with originally. We started with an x squared. We divided it by an x, which is a degree of 1. So if we had a degree of 2, we divided out a degree of 1. I removed 1 degree. We just descend by 1. So this started with x squared, so this is going to start with x. So it's going to be a 1x, which of course I can just write as x, and then descend from there. So this is a positive 10. So if you're descending from x, then x is a constant, so just plus 10. Your remainder is 0, so you don't need to write it if there's no remainder. X plus 10 is the answer. That's what we get when we divide the original polynomial by x minus 3. Let's try another. We're going to take 4a to the 4th plus 2a squared minus 4a plus 12, and we're going to divide it by a plus 2. We want to check and make sure this makes sense for synthetic division. We're dividing by linear. It's only an a, it's not an a squared. It's a binomial, 2 terms. Lead coefficient is 1, so it fits the bill. So take the coefficients here. So this is the dividend, the coefficient of the dividend. We got 4 initially. Got a little half box out front. We know it's going to be a negative 2 there because we're dividing. The divisor is x plus 2, so we take the opposite sign, negative 2. But back to our coefficients, 4. And then if we descend from there, next should be a cubed. And notice there is no a cubed. We cannot skip it. If you skip it, you're going to miss part of your answer. We need placeholders. If there's no a cubed, I have to put a 0 there because it's 0 a cubed. Then a squared is a positive 2 for a coefficient. After a squared is a, its coefficient is negative 4. And then our constant, which is 12. Okay, I got them all. Draw your horizontal line, vertical bar, right between the negative 4 and the 12 down below. Your first coefficient always drops straight down, 4. Then multiply by the number in the box. 4 times negative 2 is negative 8. add the 0 and the negative 8, you get negative 8. It gets multiplied by the number in the half box. Negative 8 times negative 2 is 16. Add the 2 and the 16 to get 18. Multiplied by the number in the half box. 18 times negative 2 is negative 36. Add negative 4 and negative 36 makes negative 40. Negative 40 gets multiplied by the negative 2, we get positive 80. Add with the 12, we get 92. So this time we have a remainder. So here's our answer. Our lead coefficient is 4, but it's 4 what? Remember the previous one started with a to the 4th. We divided by a, so we descend a degree, 1 degree. So if we start with a to the 4th, this is going to be a to the 3rd. So 4 to a to the 3rd, and now I descend from there. So minus 8, that would be a squared, plus 18a, minus 40 is my constant. Then I have plus a remainder. So for the remainder, I'm going to write a fraction, just like we did with long division. Put the remainder in the numerator, 92. In your divisor, which was what we divided by a plus 2, not the negative 2 in the box, but the actual factor, a plus 2, and put that in the denominator. So there's the answer to that problem. Now, what about a case where you get something like this? Let's say we're going to do 8x to the 4th minus 4x squared plus x plus 4, and we're dividing it by 2x plus 1. So we're dividing by, it is linear, there's no x squared, it is linear. It is a binomial, but we have a coefficient on our x squared. If that's the case, we're going to use long division. Like I mentioned earlier, the book does show how you could still use synthetic division in this case, but I almost think and this one wouldn't be too bad of a synthetic division problem because there's so many even numbers, but ultimately it's probably easier to just do this long division like we did yesterday. So I'll do one quick long division on this one, and then that'll be the end of our notes. So 2x plus 1, I wasn't missing any terms, so I don't need any zeros. We're dividing 8x to the 4th. There is no x cubed, so that's a 0x cubed. Don't forget your placeholders. Minus 4x squared plus x plus 4. So we will not use synthetic division here. What do we multiply 2x by to get 8x to the 4th? That's got to be a 4x cubed. So distribute 8x to the 4th, and then 4x cubed times 1 is 4x cubed. I'm supposed to subtract now. 8x to the 4th minus 8x to the 4th is 0. 0x cubed minus 4x cubed is negative 4x cubed. You can drop the remainder of the terms. They still exist. I didn't get rid of them. Repeat. To get from 2x to negative 4x cubed, I'm going to need to multiply by negative 2x squared. So let's do that. Negative 2 times negative 2 is negative 4x cubed. Negative 2x squared times 1 is negative 2x squared. I'm subtracting. Negative 4x cubed minus a negative 4x cubed is gone. Negative 4x squared minus negative 2, that's like plus 2. Negative 4 plus 2 is negative 2. So I get a negative 2 x squared, then drop the rest of the terms. Now 2x into negative 2x squared. Looks like I need to multiply it by a negative x. Distribute that. Negative 2x squared minus x. Subtracting 0, x minus a negative x. That's like x plus x. That's 2x. Drop the 4. 2x plus 4. It's going to go in there once. 1 times 2x plus 1 is 2x plus 1. Subtract 2x minus 2x is 0. 4 minus 1 is 3. Now at this point, 3. Oh, sorry. I didn't catch that. Got a little bit off the screen there. So, not sure where I lost you guys at. So we had a 2x plus 4. I multiplied by 1. 1 times 2x plus 1 is 2x plus 1. Subtracted that. 4 minus 1 is 3. This 3 has a degree lower than my my divisor. So I know I can't go any further. 2x doesn't go into 3. So I'm done. That's when I have my coefficient. So that will be, or sorry, my remainder rather. So my answer, let's list what I started with up above, 4x cubed minus 2x squared minus x plus 1. And then for our remainder, write as a fraction. The 3 was the remainder, that's the numerator. The divisor, or what we multiplied by, was 2x plus 1. That goes in the denominator. So there's our solution. Now for your assignment, let me write it here, begins on page 315. I want you to do numbers 15 through 17. '20, '21. '23 through 20. I'm going to write it this way: 23 through 25. And then 26, 27, I know that's a continuation of those, but 26 and 27, those are the ones I want you to use long division on. And the reason why is because they're like this last problem we just did. There's a coefficient other than 1. So 26 and 27, you want to use your long division for those two. And then from there, number 47, 49, and 50. That assignment will be due on Monday, as is the last assignment since I'm not here today. I'll plan on checking both of those on Monday. Good luck.